Hi guys, welcome back to Databag again. So we're going to start a new video series called Azure Databricks. So in the recent times, it has been really widely used within the data engineering ecosystem, especially with for huge workloads. So without any further ado, let's try to understand what is Databricks, what is Azure Databricks, what is the tech stack and the framework and the different components we have behind it and how these components are interlinked and connected. And let's try to make it simple and try to understand and get into details. So, as you know, if you've been following me from the past, that I really like simple definitions. It's always easy for us to keep them in mind if we have to do certain discussions. So, whereas when it comes to Azure Databricks, the definition is very simple. So, Azure Databricks is a unified open analytics platform for building, deploying, sharing, and maintaining enterprise-grade data analytics and AI solutions at scale. So basically, the definition says that it's a unified open analytics platform. So I think for now, we need to just try to understand that it is a platform. They say it is a unified and open analytics platform, which is again used for deploying, maintaining, sharing, building, enterprise grade data analytics. They're not really talking about startup or small scale companies. They're really talking about enterprise grade data analytics and solutions. So especially for all the data engineers who are working on enterprise, like big corporations, and most of the big corporations, they use data bricks for their data engineering workloads, and this as a platform. And we will also try to see how it is. And the Databricks data intelligence platform integrates with the cloud storage and security in your cloud account. So here, this is very generic because it's not specifically talking about Azure, but in this case, it is Azure. But Databricks is also hosted in AWS, so we also have AWS Databricks, and you can also, standalone set up Databricks on your own environment or in your own cloud setup as well. So it has this intelligence platform which can be easily integrated with the cloud storage, because we will discuss why I really speak about storage and also computation, but in this case, storage and security. So when we talk about enterprise grade applications, security is really important, and that is where the Databricks is also focused as well, and manages and deploys cloud infrastructure for you. So we will see how it is. But for now, try to understand that this is an open analytics platform. It is unified for building uh, the, the data pipelines, just to keep it simple. And this is how you have to visualize the stuff. So it's like unified governance and unified data platform. So let's say open data lake, where you can use it for business intelligence, data warehousing, AI, and data science, ETL, and real-time analytics orchestration for scheduling your pipelines, jobs, and things like that. But when we talk about unified open analytics platform, so this is the visualization they want us to keep in mind, where it is a single platform which will be used for different use cases, different scenarios, because business intelligence is different, data warehousing is different, AI and data science, they have a different use case. Of course, ETL and real-time analytics and orchestration. So even though these are all interconnected, because for building a business intelligence or BI reports or visualizations dashboards, you would rely on data warehousing, right? And so these are all interconnected, but they would like to also keep them isolated, but it's an unified platform. Okay, so managed open source integration. So Databricks is also committed to open source community as well. This is also very important, and manages updates of open source integrations with Databricks runtime releases. So the reason why I say this is really important is because I am also one of the open source contributor, where I like to contribute to the society, and also the education ecosystem as well, providing trainings and stuff like that, and also updating documentations, and trying to mentor people. Uh, in a similar fashion, Databricks is also committed to the open source community, and that is also very important, because most of the components which we're going to discuss in a minute have been first implemented as an open source software, and then has been adapted to the Databricks ecosystem or platform. So, for example, we're going to talk about Delta Lake, Delta sharing, ML flow, Apache Spark, and structured streaming, Redash, and also a very important Unity catalog, which has been recently also been part of open source ecosystem. Also very well integrated with Databricks, which is solving a very big issue, especially the catalog, the governance part. We will discuss that. But if you see, these are all the open source projects or technologies which were created by Databricks to the open source community, and they've also built their enterprise grade applications on top of these open source projects. And if you really have to, deep dive, I think Apache Spark is where it all started, but we're going to discuss that. So, what is data lakehouse? So, a data lakehouse is a data management system. Again, one-liner definitions, my favorite stuff. Is a data management system that combines the benefits of data lakes and data warehouses. So I think by now you already know what is a data warehouse. If you're really coming from data engineering background or a BA background or a SQL database background, you would have a pretty much idea about a data warehouse. If you know a normal warehouse where we try to keep all our stuff, right? Being big companies, they have warehouses. For example, Amazon has its own warehouse where they'll try to store all their, articles, and they have a unique barcode where they're going to scan it, and based on that they know how much storage space we have left and how many articles we have, what is the SKU and stuff like that. So similarly, even for data, we have data warehouses. So we will also discuss that in a bit. And there is also another concept called data lake. So data lake is a bit different to data warehouse. So when we are talking about the legacy systems, like not even legacy, we still have those kinds of systems right now, especially the data sources, like SQL databases, where you have a structured data in form of rows and columns stored in tables. You can also create views, store procedures, functions, and stuff like that. Very much structured, and the data is in the form of rows and columns, like in CSV and Excel sheets, we can visualize that. And this is where the data warehousing concepts are coming from. And if you look at data lakes, right now we almost know it is all big data, right? Every minute, every second, we generate tons and tons of data around the world. It could be social media data, could be e-commerce data, could be real-time streaming data coming from IoT devices. It could be data coming from all the uh, from IoT devices like cameras, from the traffic information, and so it's vast, right? So this data is vast, and most of the time this type of data, we call them either semi-structured or unstructured, and they are also stored in the form of files. So there is MP4 file, MP3 file, CSV file, Parquet file, Delta Parquet file. So we're going to discuss that. So to organize and to structure these kinds of files, we have introduced a concept called data lake. So when I say we have introduced, I really mean by the market has introduced a concept called data lake. So where you can store these kinds of data. So these are not in the form of rows and columns, but these are really in the form of files. But we're going to discuss how they look like as well. But for now, try to understand the data lake house is a data management system, which is a combination of data lake and also data warehouse. So we're not saying that the SQL databases or the row and column structure has been outdated. No, we're not saying that. We still need it. So where we have acid properties and various advantages coming from there, right? But at the same time, we're also leveraging data lake. So we have a combination of data lake and data warehouse. So if you look at the data lake house structure a little bit, so you have all the data sources, right? It could be SQL database, it could be images, cloud data, audio, video data, it could be a binary file. So you store them in the object storage, and then you have a delta table. We will discuss what is a delta table. But if you really look here, you have three different layers. So this is layer one, this is layer two, this is layer three. What we're really doing is from layer one to layer two, we're doing a bit of transformation. From layer two to layer three, we're doing another layer of transformation. And then we are basically uh, serving them in the form of data marts. I really like the word serving, because I think there was a reference which was taken in one of the discussions where we have caterers who specifically serve food. So this is in the similar fashion that this raw unstructured coming from various sources has been transformed so that this can be served for data marts. It can be served for feature stores, can be served for apps as an input data. It can be served for sandboxes, dev sandboxes. We will also see that. And this is the actual data we are talking about, right? This is the actual raw data, like actual data. There is also a concept called metadata, which is stored in the form of metastore, and that is where the Unity catalog comes in to understand the really. It's all about it's a data about the data, so that's what we call metadata, and that's stored in the metastore for governance purposes. But we will also see that what I really mean by it. And if you look at this architecture, right, you have one level of transformation, second level of transformation, third level of transformation, and then we get into an architecture because they have given a name to this kinds of transformation, this kind of an architecture, and that's called Medallion architecture. So what does Medallion architecture? Just to keep it very simple, so you have three different layers. The one with the initial layer is called bronze, and then you have an intermediate layer that is called silver, and then you have a final the serving layer, which is also called gold. So what does it mean? So you have bronze, where you have your raw data, and then you have your silver, which is your intermediate stage, where you have bit of transformed data, and then you finally have your a flat and final output layer where you try to consume the data, which is called gold. But if you also try to think it in normal plain layman terms, so which has more value, bronze, silver, or gold? So obviously it's the gold, because that's where it gets more refined and refined and refined, and then you have a pure form of you call it mineral. I don't know, is it mineral or is it form of the Earth's natural element? So that's the purest form, right? And also if you see that the value for gold is higher than bronze and silver. So the reason why I'm saying is when you have the data in bronze and silver, it is still a bit of unstructured, untransformed. So the value for that is little lesser than the value you have for gold layer, because that is where you're using more computation. So this is where you're doing your transformation and then you're transforming that. And here also you're doing a bit of transformation, you're transforming and we're unifying it, right? So this is called Medallion architecture. So let's see what the definition says. So the Medallion architecture is a data design pattern used to organize data logically. Its goal is to incrementally and progressively improve the structure and quality of the data. I think this is very important. Improve the structure and quality of the data. So I think it's exactly how the gold is defined, where you don't have any impurities and it's pure gold, and then the price goes high, right? So the same way in the raw structures or in the raw unstructured data, you have so many impurities. So that is where we try to improve the structure and the quality of the data when it comes to gold, and that's where we do incrementally and progressively. And this is what we call Medallion architecture. So you have a bronze layer, you have a silver layer, and then you have a gold layer. How does the Databricks lakehouse work? So Databricks is built on Apache. So this is something I have a little bit touch based on the open source ecosystem and technologies where the Databricks is also contributing. But in this case, Databricks is built on Apache Spark. So what is Apache Spark? Apache Spark enables a massively scalable engine, again, one liner, that runs on compute resources decoupled from storage. For more information, so that is an Apache Spark overview. We will also see that. And very important thing that the Databricks Lakehouse uses two additional key technologies. So one thing, Databricks is built on Apache Spark. That is very clear. And Apache Spark is an open source technology which was built by the Databricks creators, right? Or you can say in this way that Apache Spark creators have built an enterprise company called Databricks. So initially they started as an open source project from their university. And then people started adapting it, and then they saw use cases, and then they decided that we need to add security and storage and other components to it. And then they made an enterprise level application or a company called Databricks. And then they started integrating that with Azure, integrating that with AWS, integrating that with other cloud systems, and now we call it as an Azure Databricks. Just to keep it simple, right? But we'll get into details. So the Databricks Lakehouse uses two additional technologies. One, Delta Lake, and two, Unity Catalog. And these two components are literally a game changer for Databricks. And the reason why I say that, so if you look at Delta Lake, it's an optimized storage layer that supports ACID transactions and schema enforcement. ACID transactions and schema enforcement. We will see what ACID transactions, but if you if you want to keep it very simple, so whatever the concepts we have on the SQL databases, like on the SQL data warehouses, like all the ACID properties we have, and you can use a SQL queries to get the data, right? And all the business intelligence queries which you can apply on that, and these were not possible on the files. Either you read a file, right, in the form of, let's say there is a CSV file, you read it, and then you have to, like, apply some commands on top of that to understand the file and to understand the schema of the file. But Delta Lake has changed a bit of a game there. So what basically it does is it creates schema on top of file. So that's exactly what it does. It creates schema, which is a SQL like schema on top of a raw file. It could be a Parquet file, or it could be a Delta Parquet file, right? So we're also going to discuss on this a little bit. So I'm going to get more details how Delta Lake works, what is the architecture behind it, and the other important thing is Unity Catalog. So Unity Catalog is really a very important component for Databricks and also for the growth of Databricks and also for the usage of Databricks, is because the data is growing, but the issue with that is when you have, like, huge big data, the other problem comes is the governance part. When I say governance, how do you locate the data? How do you maintain the data quality, especially for metadata? And how do you dispose the data? Because we have GDPR compliances where you have to also, like, dispose the data. For that, you have to locate the data. You need to understand the retention periods and things like that, and also the data quality. So there are so many other aspects which come into a Unity catalog, which is mainly used for governance purposes. And we will discuss also what does governance mean? What are the controls which are needed in the governance for data and for AI? So a little bit of Apache Spark. So Apache Spark is the heart of the Azure Databricks data intelligence platform. So this is something we discussed, but this is the heart because it's a technology powering compute clusters and SQL warehouses. So basically, Apache Spark is the technology behind Azure Databricks. So Azure Databricks is an optimized platform for Apache Spark that provides an efficient and simple platform for running Apache Spark workloads. So if you see in a nutshell, so you have a driver program, and that driver program has a Spark context object, and that is where you pass your code, and that code gets sent to the worker. So just to put it in layman terms, you have a primary node, and then you have all the worker nodes, right? So then when primary nodes task is to distribute the work to different worker nodes. I think if you're coming from big data backgrounds, especially from Hadoop or Yarn or HDFS, so these kinds of systems, it's more or less the same, right? So there also you have, like, um, 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 a driver node, and then you have a different worker nodes, and depending on the workloads, you keep on auto scaling and increasing the worker nodes, right? So inside the worker node, you have an executor, and within that, you have different tasks, right? So you create a job and different tasks, and these tasks will be picked up based on the workloads. And we'll also deep dive into a little bit of Apache Spark architecture and overview as well, because if you're really working on Azure Databricks, you don't need to get more details into Apache Spark and how is the tech stack and how is the framework behind it, like, what is underlying system. But it really helps to understand the flow, right? But Databricks has made it very simple for us because it is all happening under the hood. So as a user, if I'm using Databricks, I wouldn't know what is really happening in the background. It is really important when it comes to interviews also to understand the Spark architecture, to have a little bit of understanding, know-hows, how it really works under the hood. So in that aspect, we're going to also discuss a little bit deeper into Apache Spark so that you get better understanding. Okay, and finally, we are at Azure Databricks component. So let's also see that in action. But before getting there, so let's try to understand what are the different components you have in Azure Databricks, and we will also deep dive into each and every component to understand a little better. If you try to understand all the components in Azure Databricks, then there is no stopping for you. I think you know in and out about Azure Databricks. And then the only thing which would be left for you is how to integrate the CI/CD part, and also how to exile in PySpark if you're coming from Python background, or there are also other components as well. You can write in Scala, you can write in Python, you can write in SQL. So we will also explore that a bit, but that would be the only thing which would be left for you to do a little bit of training on PySpark and that library, and also championing that library. Okay. Talking about Azure Databricks components. So first one, we have accounts and workspaces. We will discuss. Accounts is something we don't have to worry about, but workspace is really important for us because we will discuss because this is mainly related to the data engineering component. So then um, also, be very careful when you're trying to spin up an Azure Databricks cluster. We will discuss what cluster is. But when you try to spin up a cluster, because you need some compute engine to run your pipeline, right? So you create a pipeline on a notebook, and then you create a job, and then you want to run the job. So you need a cluster. And while creating a cluster, you also need to define something called DBUs. So those are called Databricks units. So we will also see that. And then there is a topic called authentication and authorization. It's very common for all the Azure services. So in this case, you have a user, you have service principal, you have group, and then you have ACLs, access control list. Then you also have a personal access token. We will see how it is. And then when it comes to Azure Databricks interfaces, so you have the user interface, which is provided by Databricks itself. So where you can do your programming in the notebook. So let's say that is one way. And then you also have, REST APIs as an interface where you can use Databricks, components. Then you have SQL REST API. Then you also have a CLI, command line interfaces as well. And then we have a data management. So within data management, you have a Unity catalog, schema, table, view. So I think if you see schema, table, view, volume, delta table, metastore, catalog explorer, and DBFS. And then you have computation management. So this is where we discuss about cluster, we discuss about pool, we also discuss about Databricks runtime. And then you have jobs and pipelines UI. So you have jobs, and then you have pipelines, workload, execution contents. We will discuss context. We will discuss on this. And then you have data engineering. So data engineering is like the workspace, right? So you are kind of an IDE for your developing environment. So there we have workspace, we have notebooks, we also have libraries. So this is where we also create wheel packages and deploy there to reuse the code. We'll also see that. You have Git setup, you have AI and machine learning, Mosaic AI, or machine learning runtime. So similar to Databricks runtime, we also have machine learning runtime. We'll see that. Then we have data warehousing. So in the data warehousing, you have a query, you have SQL warehouse, you have query history, visualization, dashboard. Okay. Okay. So I think now we've seen these components. Let's also see them a little bit in action, right? So what I do, I just go to my Azure environment. So here, either you can just type Azure Databricks, and then you have it. So right now, I don't have any. Also, please try to keep in mind that this is also one of the expensive resource, especially when you spin up cluster. So that is also the reason I'm a bit skeptical in creating this unless you really have a need for it, right? So it's very easy to create using your portal. Just click. Maybe let me try to zoom in a little bit. So once you try to click on the Azure Databricks, you have a create Azure Databricks workspace. So here you can create or select your subscription. I think this kind of setup is same for all the services when you try to create within Azure. And then you need to choose a resource group. Either you choose a resource group or you can create another resource group. So let's try to create a resource group saying that Azure Databricks tutorial. Yeah, let's see that if it okay, this exists. Okay, and then we also need to enter a name for Databricks workspace. So let's try to do that. Azure Databricks oh, workspace tutorial. Let's add tutorial to it. Yeah. Region, I would like to keep it Europe. So pricing tier. So if you click on this, you can also view full pricing here. But also please have a look at this. So they have extensively mentioned, what kind of, based on what kind of workloads or which type of pricing tier you need to also select. You have, standard tiers and you have premium tiers. And this is also what we discussed, DBU, Databricks unit. So per hour, it's going to charge $1, right? If you use all-purpose compute, then it's going to charge 0.4 US dollars per hour. So it's very important that you also choose based on what you need. So let's try to choose standard and so here managed resource group. Azure DBX tutorial, something like that. And next, yeah, I'm gonna leave it as is. The encryption, you can also leave it as is. We will discuss them later when we are also discussing about CI/CD. And security and compliance, also leave it as is and just try to, yeah, now it is trying to validate. Okay, validation is successful. And now if I click on create, I think initializing the deployment. So this is the deployment I'm doing using the portal, right? But usually in live environments or in your work environments, you don't do it. I mean, for a POC or MVP, you can directly use the portal. But usually we follow Azure, we use Azure DevOps or CI/CD or any other CI/CD tool for the deployment. So we're going to also discuss a bit about how you can use, Databricks CLI commands to also deploy the Databricks environment, the infrastructure using bicep templates, and also to deploy the code from your notebooks. Okay, so I think, yeah, it has initialized it. I think it's going to take a few minutes, so I will be back once the deployment is done. Yeah, says the deployment is still in progress. Yeah, you can also see under the hood how it creates and what it creates. So the first thing it is trying to do is Azure Databricks service is created. Okay, so it has created this service. Let's close this guy. Yeah, let's see what else creates. Yes, so the deployment is succeeded. You can see that here, and yeah, I think it took quite some time. But anyways, so if I click on go to resource, so here you can see Azure Databricks tutorial workspace. So this is what we've created, and then this is the Azure Databricks service, and then you have quite few options here. So these are pretty same for all the services Azure provides. You can also check the IAM and all the networking and everything here within the settings. We'll also discuss why this has been disabled, because while creating we haven't selected them. And now if I really wanted to go to this workspace, so here this belongs to this resource group, region, the subscription, the ID, and the pricing tier is what we've selected, and the URL for this workspace, and the managed resource group. We'll also discuss what managed resource group, what is the managed resource group, because if you remember while creating, there was an option to give the managed resource group name, and we gave this. But if I can quickly click on this, yeah. So this is again a managed resource group, and within this you see there is a managed identity, a storage account, a NAT gateway, a public IP address, and a security group, and a virtual network. So we will discuss, like, these are automatically created for us by the Databricks deployment when we did from the UI. But why we need this, what are the uses of these, and we will also discuss that. Now let's go back to the workspace. And here, if I click on launch workspace, and it redirects to this URL, which we've seen. And this is a unique URL for my workspace. And that is also the reason why it took some time. And here you can see that it took me to a new tab. And here, yeah, so this is basically the Databricks workspace. So for the first time, if anyone has created this for the first time, so this is basically how it looks like. And here you have a couple of options we discussed. We've discussed a very little on workspace and the catalog, jobs and pipelines, compute, data engineering job runs, and then this is AI ML. We will discuss this in a bit. So if I click on workspace, yeah, so right now there is nothing. And catalog, also nothing. So by default, it gives us a Hive Metastore, and like we discussed, there is also Unity catalog. Right now, it's not here, but we will discuss how to activate that. Jobs and pipelines. So no jobs, no pipelines. Job runs, pipeline runs. So there you can see, because it's pretty new workspace, nothing has been created there. If I click on compute, so this is where you can also create your cluster. We will also discuss how to do that. Job compute, you have pools, you have apps, lake-based Postgres. We will discuss that. And yeah, I think that's pretty much. And if you click on your account, then you have a couple of options here. If you click on settings, so here you can see IAM, Identity Access Management. We discussed users, groups, service principals, right? You can manage them here. Security aspect. And most importantly, if you click on a developer, there you can also create access tokens. We also call them path tokens. We'll discuss this as well. So yes, I think more or less this is the introduction for Databricks. So don't worry. I know it's too much information. So I know try to consume it, take a day or two, and then in the next session or in day two, we will be discussing more in depth about Apache Spark, Delta Lake, and then we will come to Databricks, and we will also see how we can deploy the Databricks using a UV library, which is pretty new in Python, which makes it very easy. I'll also show that, and the CI/CD setup, and also let's try to create a few use cases, real-time use cases to play around with the data and to do a little bit of transformations, create pipelines, deploy them, and also run them if possible. And I'll also try to explain how it really works so that it really helps for you to clear your interviews and get started with Databricks if you wanted to work with Databricks and use this cool. Okay. I think with that note, thank you so much. And yeah, please subscribe the channel because I think it really means a lot. Thank you so much for everyone who has already subscribed. But if you're really new, please subscribe the channel so that you get early notifications. And we're going to also release more and more content. Right now, it's Databricks and also Azure DevOps. We already have a bit of data factory, but I'm going to add also more content there. And there are so many Azure services and also other services are also going to come in future. So please subscribe so that you'll be notified and follow us in LinkedIn, databag.ai. You can also follow me, Vinod Kumar Bovi, in the LinkedIn. And thank you so much for your patience and see you in the next video. Bye.